Today's Daily Dose of Math is about Principles 5, 6, and 7 from the MTH-4273 Geometry course. In this course, the student gets a list of principles that are attached to the exam. And this is a good time saver for the student, because if the student has to apply one of these as a step in one of their questions, instead of having to justify what they've done by writing out one of these long sentences, the student can simply say, I used principle 6, or I used principle 5, whichever one they used. And that saves a lot of time. These principles are used for judging whether two triangles are similar. Principle 5 states that if two angles of one triangle are congruent to the two corresponding angles of another triangle, then the triangles are similar. Well, that is what I used to call the AA rule. In an older geometry course I used to teach. AA stands for angle, angle. Principle 6 says if the lengths of the corresponding sides of two triangles are in proportion, then the triangles are similar. We used to call that the Sss Rule. And Principle 7 says if the length of two sides of one triangle are proportional to the length of the two corresponding sides of another triangle, and the contained angles are congruent, then the two triangles are similar. Well, that's a really long one, and I'm glad if I don't have to write out that whole paragraph in an exam. And that is what we refer to as the SAS rule. Side, angle, side. Here I have three simple examples where I'm going to apply these principles. In the first example, we know that both triangles have a 90-degree angle, and the first has a 30-degree and the other has a 60-degree. So in trying to apply Principle 5, I need to know the corresponding angles, and in each case I'm missing one of the angles I'd like to look at. But I know that the three angles in a triangle add up to 180 degrees. So if I say 180 degrees minus 30 degrees minus 90 degrees, I get 60 degrees as the missing angle in this triangle. And I don't have to do this step again with the other triangle, because at this point I can see that I have a 90 and a 60 in both. I have enough information to say, yes, these triangles have to be similar. And my justification is Principle 5. So I write a 5 with a circle around it. I've justified what I've done. I also want this calculation because it was a necessary step in the process before I could have enough information to apply Principle 5. In the second pair of triangles, we only know sides. And so we want to try to apply Principle 6, where we're seeing if the corresponding sides are in proportion. And what I can do is build what I call a triple proportion. 100 over 50 is equal to 160 over 80. Both of those simplify to give 2, but is not equal to 160 over 75, which actually reduces to 32 over 15. So that is not equal, and the two triangles failed the test of Principle 6. So my answer is no, and my justification is I'm using Principle 6 along with these calculations that show that it is not proportional. In the third example, I have a 100-degree angle in both triangles. The side lengths in the first one are 6 and 4 of the two sides that I know, and the side lengths of the second one are 3 and 2. I can apply Principle 7 here. I can see that 100 degrees equals 100 degrees, so the two triangles are obeying that part of the principle. And when I check for proportionality, I can see that 6 over 3 is equal to 4 over 2. Both reduce to give 2. So I have enough information to say, yes, these two triangles are similar, and my justification, besides these calculations, is that I used Principle 7. Remember that with this one, it is important that the angles that you're using are contained in between the corresponding sides that you're using. And that is indicated also in the old name SAS. The A has to be in between the two S's for it to work. Yes, these are simple examples, and there are many other scenarios that could happen. But I don't want students to think that they have to be familiar with dozens of different possible scenarios. That seems like too much. But the value of these three principles that judge similarity is that you don't have to know dozens of different scenarios. If you're familiar with these three principles and how they work, then whenever you're in a situation where you need to judge whether two triangles are similar, you should be able to figure out which of these principles applies and then apply it, much like I just did. Remember also that if you're studying this same type of math, but in a curriculum other than the one I'm teaching in, if you're not taking Math 4273, you may have these principles and others. You may be responsible for knowing these, and you may have a list of principles as well, but in your list, they may not be 5, 6, and 7. And as an example, I teach another course called Math 4153, which has principles in the same sort of way, but it doesn't have as many, and that changes the numbering system. In that other course, these three principles exist, but they're called 4, 5, and 6 instead of 5, 6, and 7. So be careful to apply the list of principles that goes with your course. That is today's Daily Dose of Math. Please subscribe and share, and press that thumbs up button.